Okay, let's briefly talk about confidence interval. So, confidence interval is formulated to show the likely range of an estimate so that we can ascertain how precise is the estimate of effects. And the effect can be any statistics like the mean, the median, the regression coefficients or the betas, the proportions, the percentages, the correlation coefficient, or any parameter that describes or summarizes the data. And confidence interval can be used to show the extent to which an estimate could be accurate. The confidence interval is constructed to establish a range of values for the unknown estimated population parameter, as well as the probability of being right. And this probability of being right is also called the degree of confidence for the estimate. And once again, the estimate can be the mean, the median, the regression coefficients or betas, the proportion, the percentage, the correlation coefficient, or any parameter that describes or summarizes the data. The 95% confidence interval or the 99% confidence interval are the most commonly used confidence intervals. The 95% confidence interval means that we are 95% confident or sure that the true effect size lies within the boundaries specified by the confidence interval. The 99% confidence interval means that we are 99% confident or sure that the true effect size lies within the boundaries specified by the confidence interval. The confidence interval can be determined by the sample size. I mean, the width of the confidence interval can be determined by the sample size. The larger the sample size, other things being equal, the smaller or the narrower the confidence interval. So, this is the formula for the mean. We are all familiar with this. And when we increase the sample size, the mean may decrease because of less variability in the larger data. And the second formula refers to the standard error or the standard deviation of the sample means. And when we increase the sample size, the variability in the larger data set may decrease, and this can lead to a smaller standard deviation. And this in turn will lead to a smaller standard error. And because the mean may decrease when the denominator or sample size gets larger, and the standard error may also decrease when the sample size increases. And because of that, we may get a smaller confidence interval when the left side to the plus minus sign may decrease and the other element, the standard error, on the right side of the plus minus sign may also decrease. With that, this may lead to a narrower or smaller confidence interval. And the confidence interval can also be determined by the probability of being right. The probability of being right is also called the degree of confidence. The higher the probability of being right, or the degree of confidence for any given effect, whether it's the mean, the regression coefficient, or the proportion or the percentage, and so on, we are going to get a wider confidence interval. And because of that, the 99% confidence interval is wider or larger than the 95% confidence interval. The 99% confidence interval has a larger margin of error than the 95% confidence interval. This means that the level of precision is lower for the 95% confidence interval. And because of that, the 95% confidence interval has a lower level of precision because it has a smaller margin of error than the 99% confidence interval. And if you can see from the equation, if the mean stays the same and if the standard error stays the same, the one written in red letters, the z to the subscript of 1 minus alpha divided by 2, we call that the confidence interval, and the whole thing highlighted in yellow refers to the margin of error. You can Google the meaning for the margin of error for clarity. So, as you can see from this equation, if the mean is the same, the standard error is the same. If the degree of confidence is larger when it's multiplied by the standard error, it's going to give us a larger margin of error. So this is what we mean by the 99% confidence interval is wider than the 95% confidence interval. But the 95% confidence interval is more precise because it has a smaller margin of error. The confidence interval is constructed to show the extent to which an estimate could be accurate by providing the likely range of an estimate. We can think of the estimate as the effect size, and examples of an estimate or the effect size can be the mean, the median, the percentage, the proportion, the correlation coefficient, the regression coefficient, and so on and so forth. The standard practice is to construct confidence interval at the 95% level. This means that we are 95% sure or confident that the true effect size lies within the boundaries specified by the confidence interval. These correspond to p-values, which estimate the percentages of time we are wrong. And 0.05 is often regarded as the most commonly used cutoff for statistical significance. In terms of significance testing, the confidence interval may be better than the p-value because it consists of two information. It consists of X bar or the point estimate as shown in the equation above, and it also consists of the margin of error around the point estimate or X bar.